Welcome to the Linear Regression Hypothesis Test example tutorial on Google Sheets. So first things first, you want to have your data that you want to use. We've got hours spent studying and math SAT scores. We're going to have our explanatory variable, or X variable, be the hours spent studying. So here we have all the hours spent studying. We're going to have our response variable, or our Y, be the math stats SAT score. So here we have the paired up SAT score. One thing that you're going to need is you're going to need to have gotten Excel Minor on. If you haven't gotten that, you can go to your add-ons right here. So you'll need to be logged in to a Google Sheets. So go to add-ons and then, go to add-ons. And then if you don't have Excel Minor Analysis Toolpack, go to Get Add-ons. And then instead of searching for Excel Minor, it usually doesn't show up on its name. You're going to search Statistics. And then that'll be the second one. It's free. You can go ahead and hit enter and or hit free and add it. Once you've gotten out of that, you'll go back to your add-ons and it'll be in there for you. Okay, so first things first, when we are running a linear regression, we need to double check to make sure that our data is actually linear. So let's go ahead and highlight all of this, and we're going to insert a chart just to make sure that it's performing the way we want. So it gave us a column chart. We want a scatter plot. We're going to go down to the scatter plots, turn it into a scatter plot. And you can manipulate this by going over to custom if you like it or not. That looks like it's acting in a fairly linear pattern. There's no big swoops or anything. There's no huge chunks of data missing. There's a little gap right here, but nothing too big. And it's a little bit of cluster, but no one giant cluster anywhere. So this seems like a fairly reasonable set of data to run our linear regression on. Okay, so now we are going over to customize because we would like to know what the linear regression is. Go over here to series and click on that. And we want to add a trend line. So the line of best fit is called the trend line here. We are using a linear one. And if you want to know what your actual line is, you can hit label and say use equation. If you'd like to have r squared, you can hit r squared. It used to be that r squared always got put down below, and now they put it right to the side, so it's kind of hard to read. We're going to see r squared in a minute anyway, so I'm going to click that off. So here is our equation. So the next thing that we need to check, we're going to move this over because this is right in our way, is our residuals. We need to make sure that we have them and that they're behaving properly. So we're just going to make that funny. And what we need to know is we need to know, to find our residuals, we need to know the expected value. So we need to know the expected value and then we can calculate our residuals. Okay, and we're just going to go ahead and make that look nice for ourselves. And let's go ahead and make it pretty. Okay, so to find the expected value, we actually did need to do this because we needed to know the equation. If we had run the hypothesis test first, we could get the equation from there too, and it would be a more accurate version than what we have, but this isn't so bad. So what we want to do is we always want to say equals because we want Google to do work for us. Whenever we want Sheets, whether it's Excel or Google Sheets, to do work for us, we always have to tell it equals. So equals, well, what do we want to equal to? We want to equal to this equation. So 25.5 times my x. Who's my x value? It's my hours studying, so I'm just going to hit enter. Plus, I want my 353. I'm going to hit enter. And now, since I'm referencing my hours studied over here, I'd like the equation to drop down. You can either get your crosshairs and pull it down, or you can, if you have nothing, this only works when you have nothing below it, you can go ahead and double click and it fills out the rest. So these are the expected values. This is what the equation was expecting you to get as your math SAT score based on the hours that you studied. The residual is always the observed minus the expected. So this is equal to the observed math score minus the expected math score. I'm going to hit enter. And so this person got 65 points below what they were expected. And we're just going to bring that down. And here are our residuals. Now, one thing that we want to check is that our residuals are roughly normally shaped. How can we do that? Well, again, we can highlight them all and insert a new chart. Once again, it gives us a column chart, but this time we're looking for a histogram. So we're going to scroll down and come down here to the histogram chart. And now right now, I can't tell, is that bell-shaped? In fact, maybe it is and maybe it's not. So one of the things that you're going to want to go to is go to Customize while you're clicked on this chart and go to your horizontal axis. And we'd like our axis to be even around the x-axis so that we can see whether or not it is doing what we want it to do. So our minimum to our maximum, we're negative 125 to positive 185. So let's make it negative 125 to positive 125. And now we can see that's a much more normalish. It's a little low here on either side, but this is acting much more like a normal bell curve. And what that does is it made our bins, you can see our bins are nicely shaped. And so now we have these nicely shaped bins. And so that's allowing us to see this lovely normal shape. So our residuals are normally shaped, and now we can move on. So now we're key to running our hypothesis test. So we can run a hypothesis test. Now to be able to run the test, we need to go to XLMiner. So we're going to go to Add-ons, and we're going to go to XLMiner Toolpack, hit Start, and what you want to run is there's lots of stuff. You want to run the linear regression. That's what we're running. And now one thing that I didn't mention at the top of the video that I do want to mention here is that sometimes XLMiner doesn't like to play with Google Chrome, so it is better to open your Google Sheet in pretty much any browser other than Google Chrome. To know whether or not it's working, be highlighted on any square out here. You're just going to click in, and if it pops up the squares that are highlighted, it's working. So I'm highlighted over here at K22, so it plopped in K22. This can be really irritating sometimes, so you want to click away once you have it good, which means the square isn't highlighted anymore. So my Y range, those are my math SAT scores, so I'm going to highlight my math SAT scores. I don't have to delete anything. I can just go back over here and re-click in the box, and it magically lights up the right thing. Now if you do this, and then you click over to the X range, oh, dang it, now it thinks my X range is my Y range. I'm going to click away again. I'm going to come over here, I'm going to highlight my X's, and I'm going to come back over and have it fix my X's. Don't try and manually type this in. It gets weird about that. Okay, now notice that when I did that, I highlighted the labels Hours Studying and Math SAT Scores. You're going to want to go ahead and click that. It's much better if you include your labels because then you don't have to go looking for everything and it's in there. You don't actually need this. This is only if you want a confidence level other than 95 because it already sets that in there. If you would like to have it calculate the residuals so that you can double check what your residuals were against it, again, remember we used a rounded equation, so the residual numbers will be slightly off, but you can double check that it's going to look nicely. Okay, the last thing that I haven't clicked on here is this output range, and the output range is just what square do you want it to spit the data out. Now notice that what you're going to notice is that it goes down and to the right. So you want to make sure that it's clear. So choosing, like, say, this square would be a bad square because my histogram would be covering it up. So I kind of just want to pick something that's clearing away. I could pick this one. I could pick pretty much anything that's going to be clear of all my other stuff. I'll pick that right there. And just go ahead and figure out, it only needs one box. And then just click on it. So A29. We're going to say I've got everything. I'm going to hit OK. And here we go. Here's my summary output. This here is my R. So remember how I said earlier, whether or not we needed r squared. So there's the r, that's my correlation coefficient, and it gives me my r squared as well. It tells me how many observations, so this is our n. What was I looking for? And then it gives us our degrees of freedom. So the degrees of freedom, if we were going to calculate our p-value by hand, this is what we would use, our degrees of freedom 18, which is kind of nice because you can go back and calculate your using the t that it gives you and your degrees of freedom to double check that it is giving you the correct p-value. And then now it's running it on both the intercept and on the slope. We only care about the slope, so this is what we're caring about. Oops. Here we go, is our slope. And so this right here is the actual slope, 25.32, and if we go look, what did it say? 25.3. So here is secretly, this is the other piece that we care about. This secretly, maybe I'll highlight this in a different one. This is secretly our equation. So our equation really is y equals this number, oops, copy, times x plus this number, because that is our intercept. So really our very expanded version of our equation is this right here. Our coefficients are secretly hiding right here. This is a approximated version of those two. So if you want the nice long version, you can get it down here by running this. This is the standard error. So like I said, we're only running our regression on the slope. So here's the standard error of the slope. Here's the t statistic for our hypothesis test. So again, if we were calculating our p-value by hand, we would use the degrees of freedom 18 and this t statistic of 11.05, and then it would spit out this p-value. Now remember, the p-value is going to tell you whether or not you get to reject or fail to reject your null hypothesis, and that's based on what we choose as our alpha. If we were building a confidence interval, this is what we would be using to build our confidence interval. We're not doing that currently, so I won't talk about it. And then down here, you can see it gave me my residuals. And right here, this column right here, is my residuals. And we can see it matching up, so negative 64.4 and negative 1.1. And here I am at negative 65 and negative 2.5. So it is fairly off, because this was actually pretty well rounded. Wow, that was actually, I'm surprised at how off this is. But if you look, that's a pretty hard round from what we have down here, so I'm not surprised that the residuals are a little bit off. If you want to double check, you can actually even go ahead and highlight these, and you can say insert your chart, and you can run your histogram off of that data just to double check. If you feel like it's really off, you can go ahead and run the histogram off of that. They really ought to be about the same, because they'll be off by about the same much, or the same amount. So again, we'll do it negative 125 to positive 125. And there we go. And we can see, again, it didn't affect it. It is roughly normally shaped. Okay, well, I hope that this helped,